Now we're going to just focus on implication. Recall that for P then Q, they had the following scenario. P then Q, it was like this. They had, okay, P, Q, P then Q, true, 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 false, 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 true, true, false, then false, true. This is what we learned. This is what we memorized. This is what logic requires, right? Well, now I expect you to ask, what if I want to construct a truth table for not P, then Q? What if I want to construct a truth table for P, then not Q? What if I want to construct a truth table for not P, then not Q? What do I have? What are my choices? What are my options here? Very good. So let us begin. In each scenario, we have two letters, two simple statements. It means that we get 4 combinations, right? 2 to the second, 4. 2 to the second, 4, and 2 to the second, 4 combinations. Let us begin. Not P, then Q. It means that we need to have the negation of P. Well. Okay, let's take a look at our table. Here I have P. I have Q. True, 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 false, false, true, false, false. In this scenario, I also need the negation of P, right? The negation of P. What is the negation of P? Here, P is true, the negation of P is false. P is true, the negation of true is false. P is false, the negation of false is true. P is false, the negation of false is true. Now what? I'm done with not P. I can just construct not P, then Q. Not P, then Q. Here we go. So let's see. Guys, ignore P. We don't need P anymore. We're done with P. Just make sure you follow the order. False, then true. False, then true is true. Not P comes first. You have not P, then Q. False, then false. False, then false is true. What else? True, then true. True, then true is true. Then you have true, then false. True, then false is false. Well, this is the truth table for not P, then Q. As you can see, the truth tables are all different from each other. What if I have P, then not Q? P, then not Q. Okay, let's see. P, then not Q. P, Q. So far, I must have P and Q. These two columns are fixed. I have true, 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 false, false, true, false, false, all 4 combinations. I also need to have negation of Q. So in your next column, you're going to construct the negation of Q. True, the negation of true, false. False, the negation is true. True, the negation is false. False, the negation is true. Now the last column, P, then not Q. So now you're going to ignore Q and just connect true to false. True implies false. True implies false is false. Next one, true implies true. True implies true, true. False implies false. False implies false is true. False implies true is true. Here we go. And finally, true, then false, true. Remember that. The starting is false, then true. Guys, make sure you keep the order. For part C, we're going to have the exact same table with the first two columns given to us as follow. Okay, here we go. P, Q. Well, it should be a little bit different. Why is that? Because we're going to have the negation of P, also negation of Q. So let's write these down first. True, 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 false, true, false, true, and false, false. This is a false. I need not P. I also need not Q. Not P, not Q. And the last column will be dedicated to not P, then not Q. Okay, so forget about your Q. Find the negation of P. False, false, true, true. Forget about your P and not P and write down the truth values for not Q. False, true, false, true. Very good. And now what? Now forget about the very first two columns and then write the last column, which connects not P to not Q. Not P to not Q. False, then false is true. False, then true. False, then true is always true. True, then false. True, then false is always false. True, then true is always true. Very good. So as you can see, we have three different tables for three different compound statements, even though they are all implication, but as you can see, the truth tables are different from each other.